In this video, we will talk about normalization. So what is normalization and why do we need normalization? Note that when we follow the steps that we previously outlined when we transform the ER diagrams or enhanced ER diagrams into relational models, this will typically result in well-structured relations. But this is not a guarantee that all anomalies are removed. So normalization is the process of deciding which attributes should be grouped together in each relation so that we get rid of anomalies. Now I said the term anomalies two times. So what do I mean by anomalies when it comes to databases? Now to understand what anomalies are, we need to understand the three types of anomalies that we will have in databases. We will have insert anomaly, which is adding a new row may force the user to create duplicate data. So we call this insertion anomaly. Now we have another type of anomaly, which is the deletion anomaly, which is when deleting rows, this may cause some loss of data that would be needed for future rows. And finally, we have the update or modification anomaly, which is when changing the data in some row, this will force the change to other rows because of duplication. So let's see some examples that will clarify things up. Now, suppose that I have this table. I have columns, staff number, staff name, position, salary, branch number, and branch address. Now, let's see what sort of anomaly that we can get in here. Let's start first with insertion anomaly. Now, will we have any problem with insertion here? If we rely on the staff number as the primary key, then can we insert a branch without any staff in it? Note that the primary key is going to be required, so we will not be able to insert that record without having to insert that primary key. And this is an example of insertion anomaly. When we set the staff number in this specific example to the primary key, we will not be able to insert any new branch without some staff in it. And another thing is it's going to be determining the employees, so we'll have some kind of duplication as well. Now, what about the delete anomaly? So if we look at this specific table, if I try to delete one of the records, let's say this record, if I delete this employee SA9, now if we look closely, we have this branch that is not repeated in this table anywhere. So deleting this employee will make me lose this branch. So by the definition of delete anomaly, when we delete some data, it's going to delete some other pieces of data that we may need later on. So this is an example of a delete anomaly. Now another type of anomaly is the insert anomaly. The update anomaly, which says when updating something, we will need to update multiple records for that update to be effective, or for that update to actually update everything. Now, since we have the branch address, this branch address 163 Main Street in the table multiple times, suppose that I have a typo in one of them, either this or this or this, then I will need to do multiple updates probably. So if we spell the name of the city wrong and we spelled it here and here, then to update it I will have to update multiple records, and this is the update anomaly that we are talking about. Let's look at another example. So if we look at this, I'll give you a moment to have a look at this and see if there is any type of anomaly in here. Let's just focus on insertion anomaly. So we have employee IDs, names, and department names, and salaries, and then courses that they should take. Now, if I combine those in one table, can I insert a course before somebody takes it? The answer is no, because as we can see, the employee ID is the primary key in this case. So we have a case of insertion anomaly, which will prevent us from having a course without an employee registering that course. So we cannot just have the course in the system and offer it till someone comes and registers that course. Now, for the same table, can we find a deletion anomaly by looking at the data here? Remember that a deletion anomaly is when you delete some pieces of data. This will cause you to lose some other pieces of data that you may need later on. Now, if we again have the employee ID as the primary key, we need to look at the employees. So for example, employee 140 is the only one who is taking the tax accounting course. So if that employee leaves the organization, then we lost the information about this course. So this is some other deletion anomaly. Now, if this employee leaves the organization, I will still have this course by employee number 100, but then I'll lose the Java course and so on. So this is going to be another example of deletion anomaly. Now, can we find an update or modification anomaly in this same table? So an update is when you have to update multiple records because you want to update some kind of employee record in this case or something. So we have multiple examples. The one of the examples is when you try to give some kind of salary increase to one of the employees that have their data repeated in here. You will have to update multiple rows. And if you want to change something in the course title, you will have to update multiple rows as well. If you want to update the department name, you will have to change multiple rows as well. So these are all what we call update anomaly. Now, why do we really need normalization other than this anomaly thing? So we can just separate the tables? Is this the only thing that we need it? We actually have two major occasions during the overall database development process where we can usually benefit from using normalization. Now, the first one is when doing the logical database design, normalization concepts are going to be used in that case to verify the quality of the tables or relations that we obtain from mapping our ER diagrams into relational models. But this is not going to be our focus in this course. We want to focus on the other occasion, which is when we want to reverse engineer older systems. We will have the tables of the older systems that will have multiple anomalies, and we want to come up with a normalized database out of those older systems by removing all of those anomalies. So this is going to be our focus in this course. So we will do normalization to avoid unnecessary duplication. We will be decomposing relations with anomalies to produce smaller, well-structured relations or tables. A relation that contains minimal data redundancy and allows users to insert, delete, and update rows without causing data inconsistencies is our goal. And the general rule of thumb that you need to keep in mind that a table should not contain more than one entity type, because as we've seen in the previous example, our main problem is when we have more than one entity type, like employee information and course information. This is what's causing problems like employee information and branch information. This is again what's causing the problems. So we've talked about normalization and why do we need it and why is it useful. How do we perform normalization? Now, it will be done in stages, and each of them will correspond to what we call a normal form. A normal form is a state of a relation or a table that requires certain rules regarding the relationships between the attributes or what we call functional dependencies. So we need to satisfy some functional dependencies. So what are functional dependencies? Functional dependency is a constraint between two attributes in which the value of one attribute is determined by a value of another attribute. So if we look at this example, the customer name and the customer address will be determined based on the customer ID, because the customer ID will tell me who is this customer and where does the customer reside. So we have a functional dependency by the customer name and customer address on the customer ID. And this is what we mean by functional dependencies. Now, this is not going to be the only type of functional dependency, but we will talk about those functional dependencies.